Hi everyone, it's Mrs. Griffin with the Unit 2 Lesson 1 video about slope and point slope form. So to remind you, slope is counted by doing rise over run as a fraction. Okay. There are two versions of the formula we're going to discuss. The first one is the shortened version where we have delta y over delta x. This is the Greek letter delta, and in math we use it to represent the phrase change in. So to figure out how much change there is between two values, we subtract. So if we have two y values, as in change in y, we would take one of them and subtract the other one. And if we had two x values, as in change in x, we would do the same with the x values. So we use this for slope by looking at 2 points and figuring out the change in x and change in y and creating that fraction. So as far as the x1 and x2, y1 and y2 go, they refer to the x value and y value for point 1 and the x value and y value for point 2. So to do our calculation, we subtract. So we're going to do y value change. So y2 minus y1 would be 4 minus 1, and x2 minus x1 would be 5 minus 3, and we would get 3 over 2, and that is be the slope between these 2 points. We're going to do the same thing for part B. So we have 0 minus negative 6 for y2 minus y1, and x2 minus x1 will be negative 1 minus 3. Don't forget that minus a negative is really adding, so this becomes 6 over negative 4. To simplify this, they're both divisible by 2, which would be 3 and 2. And then negative signs, we usually don't leave them on the bottom. A fraction only gets 1, so you either put it on top or put it in front. Okay, the next one would be 2 minus 2 over 6 minus 2. y2 minus y1 over x2 minus x1, and we would get 0 divided by 4. 0 divided by anything is 0. And then finally, 3, negative 4, and 3, 0. If we do y2 minus y1 over x2 minus x1, we end up with 4 over 0. Now, having a 0 in the denominator of a fraction is not something we typically have. You're not allowed to have that. When that happens, we say that the fraction is undefined. So the slope for part D is undefined. Now next, I've plotted all of the points for each one onto one of these graphs. There are 4 types of slope. If I were to connect the points that I've plotted here, you can see that here I end up with a line that goes upward, and a line that slopes upward is said to have a positive slope. So if it goes from the bottom left upward towards the top right like this line does, it has a positive slope because the number for slope is a positive number. That fraction is positive. When we look at the second one here, these ones slope downward. They go from the top left to the bottom right. Sloping downward is saying to have a negative slope, and that is because the slope in number form, the fraction itself, is a negative number. To help you remember that, it kind of looks like the letter N if you were to do that. The third one, if I were to connect those 2 points, you get a horizontal line. Horizontal lines have 0 slopes. The slope is actually the number 0. And so if we have something with a 0 slope, the number is 0. And then finally, undefined is the name of the one we're going to get for here, just like the fraction was undefined. And those lines are vertical. They have undefined slopes when they are vertical lines. So that's how they look on the graph. So anytime you see a vertical line, it has an undefined slope. A 0 slope is a horizontal line. Upward sloping is positive, and downward sloping is negative. There are ways to help you remember that if you choose to. I showed you the N. You can also remember a Z for 0 and a U for undefined. Okay. Now there are 2 forms of the equation of a line that we discuss in geometry. In Algebra 1, you talked about slope-intercept form, which you often just referred to as y equals mx plus b. In that, m is the slope and b is the y-intercept. there is another format we're going to discuss in geometry called point slope form. That format looks like this. And it's useful when we don't know what the y-intercept is, or when the y-intercept is fractional. M is still the slope, but instead of knowing the y-intercept, we use any old point, and that point is x1 and y1. So if ever you don't have a y-intercept and you don't feel like finding it, you can just use any old point if you're going to use point slope form. So for example, in number 1 here, we have a line that goes through the point 5, -2, and has a slope of -3. If we're just writing in point slope form, then all we have to do is y minus the y value, -2, equals m, which is the slope, -3, and then x minus the x value of 5. Don't forget that minus a negative ends up being a plus. So that can be done if we're in point slope form. That is a way to write the equation of a line. If you need slope-intercept form for whatever reason, you can do one of two things. You can do what you did in Algebra 1 and plug in x, y, and m and then solve for the y-intercept. So y equals mx plus b, if you were to plug into this function, or into this equation, it would be -2 equals m is -3, x is 5, and then you'd solve for b. So we would get -2 equals -15 plus b, and b would be 13. And so your equation would be, don't forget your slope would go in here, -3x plus 13. One of the nice things about point slope form, though, is you can actually use it to generate slope-intercept form. It's just one extra step, really. You would distribute your -3 and then subtract your 2 that way, and you would end up with the exact same answer. So if you've already written one in point slope form, there's no need to do the work in orange here. You could just do the work in purple. Okay, now for number 2, we're writing the equation. We don't have the slope, and that's always the first thing we want to do, is first find the slope. So anytime you need to write the equation, no matter which form, you need to first find the slope. So we're going to use our slope formula to do that. So y2 minus y1 over x2 minus x1. That becomes plus, and I end up with 6 over -2, which is -3. So this is m, this is our slope. I'm going to choose point slope form because I do find it faster, and so I'm going to take one of these 2 points, whichever one I prefer. I'm going to use this one, and remember that that's going to be x1 and y1, and I'm going to do y minus the y value, and minus a negative ends up plus, equals, and then you have your slope -3, and x minus the x value. And that's point slope form. You don't have to do mx plus b. Point slope form is a little faster. Same thing for number 3. We're going to write our equation by first finding the slope. 3 minus 2 over -2 minus -4, which ends up being 1/2, and then pick either point. Y minus 2 equals, put your slope in front, and then x minus -4 ends up being x plus 4. And there's your equation. All right, now to graph a line, first you're going to plot a point. And that point could be B, the y-intercept, or it could be x1, y1, depending on which version of your equation you were given. And then count out your slope to do the rest of the points. Okay, so for number 4, this should be review from Algebra 1. You're first going to plot your y-intercept as -1, and then your slope is 1/2. So remember, that's rise over run. We're going up 1 and right 2, because they're both positive, and positive values are up and right. So from your y-intercept, up 1, right 2, up 1, right 2, and you do as many as you could fit, and then you can do the complete opposite, down 1, left 2. And now you have a line. When you are doing point slope form, you could basically count everything the same way. You just start in a point that's not the y-intercept. So remember that it's y minus y1 equals your slope, and then x minus x1 this tells me that my point comes from these numbers. But the minus means that it's going to be the opposite sign. So our point is actually -2, -4. That way it would be like y minus -4 to get the plus, and x minus -2 to get the +2. So that's my point. So I'm going to plot that first. Okay, and then my slope is this -2 in front here. So a -2 is really a -2 over 1. It's going to be rise over run, so up or down first. A negative tells me down 2, and a positive 1. So down 2, right 1. Remember, this is negative, this is positive. So down 2, right 1, and then the complete opposite, up 2, left 1, up 2, left 1, etc. And there's our line from point slope form. So there's no extra work. You don't have to put anything in y equals mx plus b form first or anything like that. You just have to graph them. All right. For number 6, we have another point slope form. We're going to practice with that. So remember, whatever sign you see here, the point is the opposite. And always watch, because this is the x and this is the y, and you don't want to switch them like I almost did. And then your slope is here. So this one will be 3 over 1 for the slope. Positive and positive means up and right. So we're going to plot 4, 2, and then go up 2, 3, right 1, and down 2, 3, left 1, and then we can connect to make a line. And we've plotted from point slope form. And then number 7, we're going to do the same thing. So again, remember, this is going to be your y and this is going to be your x, but the signs will switch. So it'll be -4 and -5. And then your slope is here, and it's a -1/2. Now that negative is in front. Remember, we don't put a negative on the bottom, so it's really floating on top there. So we are going down 1 and then right 2. So to plot that, we're going to go -4, -5 first. And then our slope is down 1, right 2, up 1, left 2, and it's this teeny tiny little line here. Okay, now another thing that we can do with our slope formula is use it to help us solve for missing coordinates. So remember our slope formula. I'm going to write it up here, and we're going to plug into it. So if you look at your values here, we have an x1 and a y1 for one point, an x2 and a y2 for the other point, and it says we have a slope of 6. They are telling us the m part of our equation. We can plug that in for the m portion of the equation. So here, m is going to be 6, and then we can fill in the rest. So y2 minus y1 would be k minus 17 over x2 minus x1 would be 2 minus 4. Just to clean that up quickly, 2 minus 4 is -2. Now to solve it, I'm going to multiply by -2 on both sides. And I will get that -12 is equal to k minus 17. I'll add the 17 to both sides and get that k is equal to 5. Same thing for b. We know m, and we have our points. So m is 1/2. And then I will do y2 minus y1 over x2 minus x1. I'm going to simplify the 6 minus 2 into 4. And remember, another way to solve with fractions is to cross multiply. When you do cross multiply, you're doing multiplication, so don't forget to distribute when you do that in the pink here. So 2 is going to multiply by 10 minus k and become 20 minus 2k. And then 1 times 4 is 4. I'll subtract 20 from both sides, divide by -2 on both sides, and get k as 8. We'll set 9 up the same way, that 20 equals k squared minus k and 5 minus 4. But 5 minus 4 is just 1, and anything over 1 is really itself. So I have this equation. Because of the k squared and the k, it's a quadratic equation and has to be solved by factoring. So what you have to do is remember your algebra 1, where we're looking for numbers that add to -1 and multiply to -20. Those would be put into your parentheses here, and each one would then be set equal to 0 separately. When you solve for each one, there you go.